Audio Jungle. Audio Jungle.
So here we have to talk basically two things we have, which is nothing but center of gravity and centroid. So we should aware about the center of gravity, and another is centroid. Okay, looks like very similar but completely different. So center of gravity, basically here it is defined. It is defined the center of gravity of a body defined as the point, the point, the point through which through which through which the whole weight through whole weight of a body may be assumed to act assumed to act. So if I consider, suppose this is the a body here, okay, so we are considering the whole weight of this body is what considering one point, and where the whole weight of the body is what acting called CG. This is nothing but CG, which is nothing but center of gravity, right? Center of gravity. Now what is the centroid then? So basically centroid, it is defined as the point where the whole area of the figure, or you can say of the whole area of the figure is assumed to be concentrated, is assumed to be concentrated, okay, called centroid, or it is also called as center of area. Okay, see, if I consider, suppose this is the one shape I have taken, like this is the one figure we have taken. So the centroid or center of area is defined as the point. So we considered one point for this particular figure. This is the one point. So this point will be centroid if we assume the whole area is what concentrated at this point. Okay, so we assume that the whole area is what concentrated for this particular shape. The whole area is what concentrated at this point. So this point will be considered as a centroid. Okay, so this is the big difference between the center of gravity and center of area. That center of area also called centroid. See the another word, center of area. So means any figure, any image you can take, any shape you can take, rectangle, triangle, circular, and we consider the whole area. We have to consider it is assumed to be concentrated at one particular point, and that point will be considered as called as a centroid. So this is the big difference between centroid and center of gravity. Similarly, we'll talk about the moment of inertia. So we have moment of inertia. Moment of inertia, right? So generally, what is the moment of inertia? If you call, then moment of inertia is basically two types of the moment we have, that is called a force moment, or first moment of force, that is also called moment of force, that is called moment of force or first moment of force. And second is the second moment of mass, second moment of mass, which is also called mass moment of inertia, which is also called mass moment of inertia. So what I am going to tell, first I will consider here, first I will consider the moment of inertia, and this moment of inertia is what basically divided in two parts, is divided in two parts called as mass moment of inertia, mass moment of inertia, and second is nothing but area moment of inertia, area moment of inertia, right? Now what is called mass moment of inertia? Mass moment of inertia, you have to listen carefully. The mass moment of inertia is nothing but it measures, okay, moment of mass moment of inertia is the measures of resistance of resistance of the body to rotation of the body to rotation, and forms the basic of dynamic of rigid bodies. Okay, meaning is very clear. Suppose we have, this is the section now, suppose this is the one section we have, suppose this body is what going to rotate, it is going to rotate about this point, it is going to rotate. So what is the resistance for the rotation? Resistance of the body to rotation, if this body is what going to rotate, is going to rotate, so this body will have a resistance to oppose the rotation, so that resistance will be measured by the mass moment of inertia, right? Similarly, we can define the area moment of inertia. Area moment of inertia is nothing but measures the resistance, measures the resistance to bending, resistance to bending, and forms the basis of strength of material. It's very clear. It's very clear. Strength of materials. It's very clear. Area moment of inertia is basically it will resist the bending. Okay, like suppose this is the one vertical member. This is the one structural vertical member. Okay, if you are applying compressive load, so what will happen to this structural member? This structural member will try to bend in this direction. It will try to bend something like this. Okay, here we have bending. Okay, to resist this bending, will that structure, this vertical member will have a resistance to this bending. I mean, that resistance will be there, and that resistance will oppose the bending of this vertical structure because of this load. Because once we'll apply the load on this vertical structural member, so it will bend like this. See, this is called bending. It will bend. Or you can take horizontal structural member also. Suppose you have taken horizontal structural member, and here you are applying load. Here you are applying load P. Suppose somewhere it is kept. Okay, somewhere it is kept. So once you apply load here, so what will happen? This structural member will bend something like this. It will try to bend like this. So this is called bending. Okay, this vertical displacement called bending. Okay, so once any structural member will have bending because of the external applied load, to resist that bending, so that measurement of the resistance to that bending will be called as a area moment of inertia. Okay, so always remember, it's very clear. In short I can say that mass moment of inertia and mass moment of inertia will resist to rotation, and similarly your area moment of inertia will resist to bending. This is very special point and you need to remember this. Okay, this is very, very special point. Right, till now this one is clear. Now coming to the mass moment of inertia, if you are talking how to calculate mass moment of inertia, so it's very simple. Mass moment of inertia, in short, mass moment of inertia. Okay, suppose this is the one body. Okay, and this body you take one center point. Suppose this is the center point. From r1 distance, suppose here we have mass m1. Similarly, r2 distance, this is what? Mass m2. Similarly, r3 distance, suppose this is the mass m3. We can about this point. Okay, and this is the r4 distance. This mass is nothing but m4, right? So if you calculate mass moment of inertia, so mass moment of inertia is nothing but it's a summation of product of mass into that distance, r is the distance from the center, distance of the mass particle from the center of the body. So it's nothing but m1 r1 square plus m2 r2 square plus m3 r3 square. So ultimately it's nothing but summation of mi ri square. I means it can be any number, 2 3 4 5 6 7. So this is nothing but mass moment of inertia. This is called mass moment of inertia. Basically this will be used, mass moment of inertia basically used to measure the resistance for rotation. If somewhere rotation is there, so it will measure the resistance, and that measurement of resistance to rotation called as a mass moment of inertia, which is denoted by I. Okay, now very important, it is called area moment of inertia. Okay, also the point I want to mention here, that mass moment of inertia, what you have written here, that mass moment of inertia, basically two types of mass moment of inertia we have. Okay, that is first moment of inertia, and that is called that first moment of inertia, which is also called first moment of force, and we can have the second moment of force also. Okay, second moment of force. So now this mass moment of inertia is what done. Now we'll go for the area moment of inertia. Okay, area moment of inertia. Area moment of inertia. Okay, area moment of inertia. 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 I will tell you what is the mean of first moment of inertia and second moment of inertia. You will understand, it's very easy. So area moment of inertia, now you are going to talk. In area moment of inertia, we have to take two parts. One is called first moment of area. First moment of area. There should not be any confusion. Area moment of inertia I have written. So this is the second moment of area. Okay. Second area moment of inertia, basically two parts, first moment of area and I have to write second moment of area. Second moment of area. Okay. If you talk about the first moment of area, so just see, first moment of area, basically if you take any system, if you take, okay, so for the system, if you want to find the centroid of an area, then we have to use first moment of area. So for the calculation, because centroid I have explained you, centroid is nothing but it is defined for the area. Centroid is nothing but it is defined for the area here. See, center of area, centroid is also called as a center of area. So if you want to check the center of area, which is nothing but centroid, then you have to use first moment of inertia, which is nothing but first moment of area. First moment of area basically used to find a centroid. So first moment of area always used to find centroid of area. And why second moment of area will be used? So second moment of any area will be used to find just here only I had explained. See, centroid, center of area, basically it's the point where the whole area of the figure is assumed to be concentrated. So once you are going to calculate first moment of area, then it will give the centroid. But if you go for the second moment of area, then it will give the moment of inertia. Okay, and moment of inertia, basically to find moment of inertia, you have to take second moment of area. Okay, now how to do this? It's very simple. I can take for both, I am first moment of area and second moment of area. How to take it? Simple. See, I can consider, suppose this is the one section we have here. Okay, this is the section, right? Now for this section, I just say the area is nothing but A. I can take small portion, which is nothing but dA. One small portion I have taken here, it's nothing but dA, and this is nothing but x, this is nothing but y, right? So polar, I'll tell you what is the polar moment of inertia also. I just want to show the radial distance. This is what r. Now you can check, this is parallel to x axis, this parallel to x axis will be x, and this parallel to y axis will be y here. Okay, and this is nothing but origin. Okay, correct. So now for this area, because you have taken this area, basically elemental area, you can say it's something like this. I can show you nicely so it will be more clear. This is nothing but area. Okay, this is dA. Now onward, how to calculate first moment of area? First moment of area, listen carefully. Moment is what? Moment is nothing but, because we are calculating for the moment, so we have to take somewhere, this is the area dA section we can say, and this is the perpendicular distance, you can say perpendicular distance x. Okay, so your first moment of area is nothing but integration x into dA is nothing but first moment of, it is called first moment of area, it is called first moment of area x dA. Okay, first moment of area, moment of area. It doesn't mean, it can also be YDA. Okay, YDA. So what it will give? It will give the centroid. It will give centroid because first moment of area will give the centroid. Okay. What about second moment of area? Second. We have to write the second moment of area. Second moment of area. So for the same diagram, you can say, because first moment of area you have, suppose this is the dA, and we have taken, suppose this is what x, this is what y. Okay, and about this point you are talking, this is nothing but r. Okay, you just say this is what 0, that is origin. The same diagram I'm taking. So now second moment of area, how to write second moment of area? First moment of area, what you have taken, it was x dA, first moment of area, into again one perpendicular distance x. So this is the first moment of area into perpendicular distance, one more distance you have to multiply, then it becomes second moment of area. So it becomes now x square dA. Okay, if you are checking for x square dA, then where, if you are saying x is perpendicular distance, so x is perpendicular distance for what? For y. So for that reason, this will be the moment of inertia Iyy, which is nothing but x square dA. Okay, similarly Ixx, so for Ixx, for xx axis, what is the perpendicular distance? It is y. So now Ixx is nothing but y square dA. This is the second moment of inertia. So basically you got that second moment of inertia, second moment of area, second moment of area, also called as moment of inertia. So generally whenever we'll talk about the moment of inertia, means we are talking about the second moment of area. And second moment of area, now that formula is clear, you have to calculate for the x axis, it is nothing but y square dA, and for y axis it is nothing but x square dA. This is the formula you need to remember. Okay, this is the formula you need to remember. Right, and if you want to calculate, that is zz, it will be the polar coordinate system. So izz also you can calculate here, and that I will tell you later on. Ixx and yy, it is called, basically it is called second moment of area. Okay, technically I have explained you two types of moment of area we have. Area moment of inertia, or it is also called moment of area. Moment of area. The moment of area, basically we have two types. One is first moment of area, another is second moment of area. First moment of area basically used to calculate centroid of area, and second moment of area is used to calculate moment of inertia. So always remember, second moment of area always called as a moment of inertia. So whenever we are talking about the moment of inertia, the moment of inertia is basically second moment of area. First moment of area is only for the calculation of centroid, which is called CG. Centroid, if it is area, so obviously you have to check any point where we assume that whole area is what concentrated. So that is centroid. Okay. Now onward, based on this, we have a two theorem, because one here I-axis and I-y-y, we have assumed two axes, I-axis and I-y-y. I will show the section, then it will be more clear to you. Suppose now this is the body. Okay, so for the body, suppose this is the axis, this is the y axis, and this is what x axis, and your CG is here. So if CG is here, then only you can write I axis, that is y square dA, and Iyy is nothing but x square dA. That is true. That is true. When axis is what passing through the CG, then this is the formula. That is true. No problem. But this object is what somewhere another place. Suppose this object is what here, but I'm talking about this axis. My axis is now changed. Now this is x axis and now this is y axis. Now for this object, suppose we want to calculate second moment of area, which is nothing but moment of inertia. Now for this object, if we want to calculate moment of inertia, which is not passing, where the axis is not passing through the CG of this object. For this object, suppose this is the CG, but my axis is not passing through the CG. My axis, suppose x is passing from some another, you can say, better I can say this distance is nothing but h. Okay, or better you say y. Y, you can say y. This axis is nothing but CG, you can say. This is what CG, center of gravity. You can call it, this is CG now. Okay. Now I want to calculate I axis. So how to calculate the moment of inertia I axis for this particular body? It's very simple. I told you I axis directly you can write y square dA integration, which is second moment of area. But this will be possible when the axis is what passing through the CG of the body. But here see, this axis is not passing through the CG of body. This x axis is away from CG, and it is away by y distance. Then how to calculate I axis? For that only we have a theorem which is called parallel axis theorem. Okay, we have parallel axis theorem. Okay, now if you apply parallel axis theorem, what is the parallel axis theorem? Simple. If you calculate parallel axis of theorem, so the rotational inertia about any axis is the sum of second moment of inertia. But parallel axis through the CG, the total area of body times square of the distance between the axis. So through the parallel axis theorem, if you want to calculate I axis, so I axis is equal to this moment of inertia through CG plus area of this body. Just say the area of body is A. The area of body is A, and this perpendicular distance, which is nothing but y square. As I told you, because we are interested about x axis, so we got this y distance. Suppose I am interested about the y axis moment of inertia. So this perpendicular distance we should have. What is this? It is x. Now you can write ICG plus AX square. This is through the parallel. So why parallel axis theorem is what required? You need to understand parallel axis theorem is required when you are calculating moment of inertia away from the CG. If you are calculating moment of inertia, which is moment of inertia about the axis, where the axis is passing through the CG, then directly you can write this moment of inertia y square dA for IXS and Ix square dA for Iyy. But when parallel axis theorem required, when you are interested to calculate moment of inertia about any axis and that axis is not passing through the CG, like here I am interested about XX axis, this is the XX axis. I am interested to calculate moment of inertia Ixs for this particular body, but this body is not this body CG is not passing through this XX axis. This body is what somewhere another place, and that location of the CG of this body is what y distance from the XX axis. So by using parallel axis theorem, we can calculate Ixs. Ixs is equal to ICG, means about the CG will have a moment of inertia. What is the moment of inertia about the CG? This Ixs is the moment of inertia about CG. This Ixx also you can say this is the ICG. There is no doubt about it. This is also ICG. This for x axis and this for y axis. Okay, because why I am saying this CG, because this y axis is passing through the CG. Hence you can write that. But here see, ICG and Ixs is totally different. It is y distance apart. It is not same. So now if you want to calculate Ixs, you have to write ICG for this body plus A is the area of this body into perpendicular distance, which is nothing but y. Perpendicular distance is square, AY is square. This is by the parallel axis theorem. This is the formula, parallel axis theorem. There should not be any confusion about it. This is the one. Second, also we have, which is called perpendicular axis theorem. So this is the parallel axis theorem. Now perpendicular axis theorem. Why perpendicular axis theorem is required? So sometimes, suppose this is the x-axis and this is the y-axis. We are interested to calculate moment of inertia perpendicular to the plane. And that plane will be, obviously, that axis will be IZZ. So if I'm interested to calculate IZZ, then we have to go through the perpendicular axis theorem. What is the perpendicular axis theorem? Second, the perpendicular axis theorem we have here, perpendicular axis theorem. So with the help of perpendicular axis theorem, we can get, suppose this is what x, this is the y-axis and this is what x-axis, and we have object, this is the object, area is A. I am taking a small element, this is nothing but dA. For this dA, if you check, radial distance will be r, this will be y, and this will be x. I am interested to calculate moment of inertia for z axis. So where is the z axis? Z axis is just perpendicular to the xy plane. Okay, so basically z axis is perpendicular to the plane of xy. Okay, and that is perpendicular to the plane. Okay, plane of xy, or perpendicular to simply perpendicular to the plane. So if I'm interested to calculate moment of inertia or second moment of area perpendicular to the plane, so that will be IZZ. So once you are interested to calculate second moment of area or moment of inertia perpendicular to the plane, then you have to use perpendicular axis theorem. And as per perpendicular axis theorem, IZZ is always Ixx plus Iyy. Okay, Ixx plus Iyy. That is one thing. Second thing also, This izz is also denoted by j, and this j is nothing but I axis integration. What is I axis? It is y square dA, and what is the I by? It is x square integration x square dA. You can write integration x square plus y square dA. What is x square plus y square? If you check this, so this is nothing but you just say theta, angle theta. So what is the r? If you calculate r, so obviously this is y, so this will also be x, parallel to this. This is x only, this is y. So what is the r? R is nothing but it's x square plus y square in root, that is r. So what is r square? It is x square plus y square. So what is the value of izz? That is nothing but j now, and it is integration of x square plus y square into dA, and this x square plus y square is nothing but r square integration dA. So basically j is equal to r square dA. This is called polar moment of inertia. What it is called? Polar moment of inertia. So generally, if it is plane like xy plane, so we'll use ixx, iyy. But suppose somewhere any spherical shape or circular shape, then we need to calculate moment of inertia perpendicular to the plane, which is nothing but z axis. And z axis, a moment of inertia also denoted by j, that is called polar moment of inertia. Moment of inertia. So generally it is used for the circular section. If I say circular section, means it may be cylinder, it may be circle directly, it may be sphere also. So for sphere, for any circular section, we need to calculate polar moment of inertia. All right, so this is very basic today what I have explained. This is very basic.